Hi all, I regretted the technology snafu surrounding the chi-squared test and the color count of M&Ms. So I created a short tutorial to show you how you could do the same statistical comparison using GeoGebra. So you'll recall that we counted the color distribution of M&Ms, and we're going to use a goodness of fit test to determine whether our bag was statistically different from a presumed equally distributed color bag, with each color contributing 1/6 to the bag. That meant that we had a null hypothesis that stated my bag of M&Ms resonates with an equal distribution of color, and an alternative hypothesis that states my bag of M&Ms does not resonate with an equal distribution of color. So to begin the test, we open a web browser and go to the GeoGebra site. Next, we'll click probability from the classic apps column of the website, and this will open the probability and statistic functions of GeoGebra. We want the statistics tab on the screen, and then we'll click the drop-down menu and select goodness of fit. Now it's a matter of entering our data. So we begin by selecting 6 rows, a row for each color, and enter the colors in the blue category column. We also need to enter the observed counts in the observed count column, and we'll also enter the expected counts of 1/6 for each cell in the expected count column, so that's 16.6 repeating. GeoGebra immediately displays the result, and in particular we're interested in this value of p. What does it tell us? Well, p indicates the risk of incorrectly rejecting the null hypothesis. So in our case, the result of 4/1000ths means there's a 0.4% chance of incorrectly rejecting the null hypothesis. In other words, a really small probability that we'd be making a mistake by rejecting HO. So let's reject HO. And that means that we can conclude that my bag of M&Ms does not resonate with an equal distribution of color. Now, to help see exactly how the categories differed, we could look at a bar graph of observed, the purple bars, compared to expected, the blue bars. We can see from this graph that the M&Ms with the greatest observed versus expected discrepancies are the ones that are colored blue, red, and orange. Now, we could also test our bag against the distribution the M&M Mars company claims each bag should contain. We need only to change the expected count column. What does the result, the p-value, indicate we should say about our hypothesis? Why should you never tell people that they are average? Ready? Ready? Wait for it. Why should you never tell people that they are average? Because that's just mean.